Hi, grade 10s. We're going to be looking at graphing lines today and looking at lines in different forms. Slope y-intercept form, which we're really good at graphing, and graphing lines that are in standard or general form. So we're going to teach you a little trick about that today. So the first one is y equals 3/4 x minus 5. And there are two reasons that I know this is a line. First of all, I see x's and y's and numbers and nothing crazier. So that would tell me that that is a linear relationship. I also recognize that it's y equals mx plus b. And I know how to graph that quite well because I know that this b value is my y-intercept. So that's the point that I know. And it could be written as 0 minus 5. So I would have a starting point right here. I know that the 3/4 is my slope, which would be my rise over run. So I could take the 1 point that I know and go up 3 over 4. I could do that any number of times actually. And I have got my line. You really do have to be impressed with how much neater I am getting. Okay, so I want to label that. I have my axis labeled, 3/4 x, subtract 5. Let's look at the equation of a line that's given to us in a different form. We have two possibilities. Number one is that we can rearrange this to y equals mx plus b form because we're familiar with that. And then we could graph from there, and that's fine. That always works. So I'm going to take this equation and I want to write it so that it looks different. So it's not supposed to be magic, it's just in a different form. So when I see this equation at the top, I know I only want the y on the left side. So the first thing I'm going to do is subtract 3x from both sides. So it looks a little bit more like the form that I want. The second thing that I'm going to do is add 12 to both sides. So at this point, I have just y on the left side, which is the look that I want. But I don't want 6y equals something, I want y equals something. So I'm going to divide both sides by 6. So my left side is now y. My right side is negative 3 over 6x plus 12 divided by 6, which is 2. So I can graph that with my y-intercept. My slope, I can use negative 3 over 6, or just remember that in reduced form, that's negative 1/2. So with my understanding of graphing, I can do a y-intercept of 2. And from there, my slope is down 1 over 2, down 1 over 2. And I have a slope of negative 1/2. Okay. There we are. 3x plus 6y negative 12 equals 0 is this line. But there is a second way to do this. Number one, rearrange. Y equals mx plus b. Always works. This particular one, the fraction wasn't all that nasty, but you know sometimes it is. So we're going to try a different method that's going to help us with all equations in general form. If I have 3x plus 6y subtract 12 is 0, it's linear, I know, because I've got x's and y's and numbers and nothing crazier than that. The second method that I can do is look for intercepts. So I'm going to look for the y-intercept. We'll pretend that we don't know that it's 2. And I'm going to look for the x-intercept. And the reason that I'm doing this is that the x and y-intercept have zeros, and that makes for very nice points. I can see them on my graph. It looks like the y-intercept is 2. Surprise! And it looks like the x-intercept is 4. But we're just going to show our work for that. The first one, we're going to show a little more work than we will for the other ones. For the first one, my y-intercept, I know that I'm going to have a point 0 something. So for the y-intercept, my x value is 0. So if you substitute x equals 0 into the equation of the line, you're going to have 3 times 0 plus 6y negative 12 equals 0. So all I'm doing is making the y-intercept point by substituting the x value into the equation. Well, 3 times 0 is 0. It's gone. I am left with 6y subtract 12 equals 0. I'm going to add 12 to both sides and divide both sides by 6, which is exactly what I did last time I was finding the y-intercept, 0, 2. For the x-intercept, that's when the y value is 0. So I'm going to have a point that looks like that. For the x-intercept, I'm going to substitute y equals 0. If I put a 0 right here, that 6y is gone. It's 0. 6 times 0 is 0. It's gone. So I would be left with 3x subtract 12 equals 0. 3x, if I add 12 to both sides, I'm going to have 3x equals 12. Divide both sides by 3, I have x equals 4. So I have 2 points now. If you have 2 points, you can draw your line. There's one, here's the other. And I could draw that same line using x-intercepts and y-intercepts. Let's do another one, just the one way. 36 equals 9y subtract 4x. This isn't either form. It's not general form or slope y-intercept form. It's just weird. So we're going to graph this thing by finding the intercepts. The x-intercept is where the y value is 0. So in order to find the x-intercept, I'm going to substitute y equals 0. That means this guy is 0. That means I'm left with 36 equals negative 4x. If you divide both sides by negative 4, you have an x-intercept of negative 9. There it is. For my y-intercept, I better write that there. For my y-intercept, that is where I have a 0 value for my x. So I'm going to substitute x equals 0 into the equation, which means that the last term is 0. If I put a 0 there, the negative 4x becomes 0. And I am left with 36 equals 9y. If I divide both sides by 9, I have an, I'm good. I have a y value of 4. So my y-intercept is positive 4. And that is enough information to be able to graph my line. Okay, let's try another one. Oh no. X divided by 2 plus y divided by 4 equals 1. We could rearrange this to y equals mx plus b, but I imagine it might make us cry a little bit. So we are going to graph this thing using x and y intercepts. For my x-intercept, my y value is 0. So I'll get a point that looks like that. If I substitute y equals 0, this fraction becomes 0, because 0 divided by 4 is 0. I'm so lazy, I'm not even going to write it down. I'm going to have x divided by 2 equals 1. If I want to solve for x, I'm going to get rid of divide by 2 by multiplying both sides by 2. That leaves me with x equals 2. My x-intercept is 2. Secondly, my y-intercept is where my x value is 0. So I'm going to substitute x equals 0. That means the first term becomes 0, because 0 divided by 2 is 0, is gone. I'm left with y over 4 equals 1. And if I want to isolate y, I'm going to multiply both sides by 4. And I have a y-intercept of 4. So my two intercepts are 2, 0 and 0, 4. That's enough for a line. Oh man. Awesome. Oops. being very bad. There we go. For one last one, we're going to graph this using x and y intercepts. So my x-intercept for this one is where my y value is 0. That would leave me with 7x equals negative 10. If I divide both sides by 7, it's kind of ugly, but I have my x-intercept. For my y-intercept, my x value is 0. If I put a 0 in for x, my first term disappears, and I'm left with 2y equals negative 10. I'm going to divide both sides of that equation by 2, and I will have my y-intercept of negative 5. So one of them's pretty, one of them's not. There, more or less. And the x-intercept is negative 10/7, which is more than negative 1. 3/7 of the way. Oh, smartboard not being nice. There's got to be some rule about labeling things in red. But anyways, our final by using x and y intercepts is this line. You've got 2 handouts to work on today, and the solutions will be magneted to the front board.